And then also you have the reticular formation. And what that does, it regulates the level of consciousness and also muscle tone. And then again, like I said, it has cardiovascular center and respiratory center. So it has to do with functions to keep the body functioning on the most basic levels, like, you know, keeping your heart beating and keeping your respiration going. So until we get the notes, I'll go a little bit slower so that you have time to write stuff down. So like I said, basically the brainstem is what controls the more vital body functions. And it has most of the cranial nerves, except for C1, the first and the second cranial nerve. So the first is going to be for your nose, and then the second is going to be the optic nerve for your eyes. And then the other one that's not in the brainstem is the spinal accessory nerve, or the 11th cranial nerve. And then also in the brainstem it has reticular formation, which has to do with general overall control of the level of consciousness, muscle tone, and then cardiovascular and respiration. Then you have the cerebrum, or the cerebral cortex. And then, like I mentioned before, you have the sulci and the gyri. The sulci appears in between, and then the gyri are the amongst. Then you have the cerebellum. That's going to be this part here. I hope so.
I'll leave the door open so it'll stay. Get some breeze on it.
And then there's 3 different ways that the cerebellum connects to the brainstem. And those are what's called peduncles. So here's the cerebellum, and there's the brainstem. There's another connection, so the superior peduncle, middle, and the inferior. Those are basically the way that the pathways connect between the cerebellum and the brainstem. And then the cerebellum is coordination. So you have coordination and also tone. So it has to do with posture, so it sets the tone of your muscles. So obviously there's certain muscles that are activated or firing within your posture. It's going to be communicated with the cerebellum. And that's even breathing. Now, when you the difference between where the neurons go in the brain versus in the cerebellum is one side of the brain has to do with the opposite side of the body. Because the spinal tracts, they cross. Okay? The cerebellum, it's the same side. So the right side of the cerebellum has to do with the right side of the body. And in that case, there's some of the tracts that cross and cross back, and there's some that just go straight up or down without crossing. And now we're going to focus on the blood supply to the brain. And one of the sources of the blood supply that goes to the brain is going to be the vertebral artery and the basal artery. Basically, there's 2 vertebral arteries that go through the cervical spine, and they merge together to form the basal artery. We'll have some pictures of that in a minute. Okay, so then you have the internal carotid artery. Okay, so you start out with the common carotid artery in the neck, and then it splits into an internal and external carotid. And then there's also these arteries as they come together that's formed what's called the circle of Willis. Because what it is it's built-in redundancy. Okay, so if one artery gets blocked, they circulate with each other. So you have the circle of Willis that goes, that ties all the arteries together. And that circulates around the brain stem. So up in this area here, it forms a circle around. And then you have, what completes the circle is you have these anastomosing arteries. So they complete the circle that goes around. So this picture on here shows the vertebral arteries that goes through the cervical vertebra and then the internal carotid artery. So then you have the right and left vertebral arteries. Like I mentioned, they merge together. They form the basilar artery. So you have the two vertebral arteries, and they come together to form one artery, which is the basilar artery that goes at the front of the brainstem. And then that's happened around the foramen magnum, which, remember what the foramen magnum is? That's the opening in the occiput where the spinal cord goes through to join up with the brain. And then those basilar arteries go up to western circles. So there's, on one of the other slides here, if you go to this one here, the picture's enlarged a little bit more. And you can see these the basilar artery is this one at the base here. Okay? And then that circle of Willis is this whole circle right here that they all form together. And then coming in from the side, you have the internal carotid artery. So this is where we left off. We've got the vertebral basilar artery, the internal carotid artery, and the circle of Willis, and then you have other communicating or anastomosing arteries. So here is going to be the vertebral artery, and it goes back behind this one. It goes in through the transverse process right here, and then it forms the basilar artery here. And then this is going to be here's the common carotid, and then it divides, and then here's the internal carotid. That's going to come up into here. So here's the vertebral artery. Like I mentioned, it goes through the foramen in the transverse process, and then it forms the basilar artery right here, and that's it near the foramen magnum. So it starts out from the subclavian, and then comes the vertebral artery, and then it goes through the IVFs, and then it forms the basal artery up here. Okay. So that's going to be coming in right here. So here's the basal artery. And then that's going to become the posterior cerebral artery. It's going to go back here. Okay. And then this is where it's going to be the circle of Willis in here. If you follow this up, here's the basilar artery, and then it's going to come back here into the posterior cerebral. So then the vertebral basilar artery and the posterior cerebral artery supply blood to the brainstem and the cerebellum. And it looks like this got cut off on the bottom of your notes then. So it also goes to the parts of the thalamus, the temporal lobe, and the occipital lobe. So it's going to be more towards the back part of the brain. Now, so here's, so now we're talking about the internal carotid artery. So first we talked about the arteries that form to the basal artery, and this one comes back to the other arteries. Here you have the common carotid artery, and right there you can see that it splits at the carotid bifurcation. So then you're going to have an internal and external carotid. So obviously the internal one's going to go more internally, and then the external is going to go more externally outside of the skull.